So what we're going to talk about right now is switching cations in a double displacement reaction. So you can kind of see up there on the overhead, and you'll be able to look at it. Yeah, so if you want to move your seat, you can.
This is the stuff I do.
You're not even doing this stuff, Paige.
What? No, you
This
said
is-
cation.
This is honor stuff.
No, I wanted. I actually.
I don't know how to do this either.
All right, so let's look at the double displacement reaction one.
Okay. Wait, which one are we on?
We're looking at the double displacement one that says NaOH and
Oh, okay.
HClO4.
Okay.
All right, come on, get my little thingy up there.
Can I just take my test on a laptop right now?
Okay, so do you notice that you have four things right here, right? You have
Yeah.
1, 2, 3, 4.
Yeah, isn't the one on the right the answer?
The one on the right is the answer, yeah?
Okay.
Now, what I want to show you for the whole switching cations thing is when we look at a double displacement reaction, it breaks down into, each of these will break down into cation and anion.
Why is the OH together?
The OH is together because it's a polyatomic ion. Anytime you have more than one element really close together, then it's a polyatomic ion. And what I'll probably do for you guys is, and you tell me if it would help a lot. You see how this one has parentheses? At this level, if I put parentheses around all polyatomic ions, would that help understand it more?
Yeah, because I didn't understand why it wasn't NaO or something like that.
Okay.
together.
So maybe what I'll do then, and that's kind of a good observation on your part, is I will make all polyatomic ions parentheses. Down the road, you guys will have to pick that out,
Yeah.
but we don't need to focus on that right now. So now what happens is for a double displacement, we need to break it down into the cation and anion. We have Na plus and OH minus. We get the Na plus because we look at the periodic table. We get OH minus because we look at the naming compounds paper and we look at the charge. So you can look it up, or you can do the reverse crisscross, meaning this is Na1 and OH1, right?
Yeah.
So all I did was I took those numbers up here.
Okay.
Now over here, we need to break this down into its cation and its anion. The cation is going to be H plus, and the anion is ClO4. What's our charge?
Minus.
Minus. Because each of these are a 1, right? Now if you look this up in the table on the naming compound chart, you would see that's under the -1 charge.
And those two balance each other out, like H and ClO4?
Yep, they balance out. That's why there's no little tiny subscripts like 2s or 3s or 4s here. Now when I say, this was your main question, was what does it mean by switching cations? In a double displacement reaction, you have a cation here and a cation here. You are going to switch them, kind of like I say flippy floppy. The Na will become an H, and the H will become an Na.
So you just switch the places of them?
All they do is switch places. So what I'm going to do is I'm going to take this H, and I'm going to write it with the OH, and it's actually H plus and OH minus. And then I'm going to take the H, it's no longer an H, because it was replaced with Na plus and ClO4 minus.
Okay.
Now you do the crisscross method. This one, anytime you see HOH, it's H2O. And that's covalent, so you're not really dealing with an ionic compound. But the other one, you are dealing with an ionic compound. And I have crisscross right here, and that gives me the NaClO4. This would be a 1.
Okay.
What I'm going to do is erase all of this right now to see if the answer makes sense to you. So your initial question was, what do you switch? You always switch your cations.
All right.
For this one, you switch your cations. And I'll actually go over this one real quick with you. We break it down into cation and anion, Ba plus 2 Cl minus 1. You can reverse crisscross, or you look at the periodic table and see that Ba's charge is plus 2.
Alright, well my dad figures it out.
Alright, I'm going to keep talking because I'm recording it. But does that help and make sense?
Yeah.
And what I got from you is, if I were to put parentheses around all the polyatomic ions, people would understand it a little bit better.
Yeah.
Okay, I'll make sure I do that. So we have Ba plus 2 and Cl minus 1. In this one, we have K. We'll see you later, Caitlin. We have K. Give me my little pen back. We have K plus 1, and we have PO4, 3 minus. So we do our little crissy-crossy here. Well, actually, before we do the crisscross, we need to switch our cations. So that means this one is going to become, and I'll write it above here because that's how they did it. We have K plus and Cl minus. And over here, we have Ba2 plus and PO4, 3 minus. Then we crisscross here, and we get the Ba3, PO4, 2. And if we do our crisscross here, we get one of each for KCl. If you struggle with what I mean by crisscross, go and look at that video section on crisscross to see what I mean by that. But that is what I mean by switching cations in a double displacement reaction. That's all I got. I'm going to stop the video recording.